with the concept. For that, what happened? You need the idea of the large sheet. That much of hint is what I can give. And what is the thing? Is asked the force exerted by one off on the other off. So is it okay? I think this will become one hemisphere. This will become another hemispherical shell. Left off, force exerted by left off on the right off. Of course, net force on the shell is zero. What is asking? What force is exerted by the left off on the right off? How come? So it is as good as like a. It is as good as like these two things, no? This is having mass, right? There's a left. So this shell is having a mass, this shell is having mass, no? And they'll exert force on each other. That force is what he's asking. But we don't know the field due to hemispherical shell. Can you apply that? Yes. Okay, we'll do one thing. Hemispherical shell. I think we did only for solid hemisphere. Can you agree this? Trying to explore what all ideas you have first. Sir, I'll find out the field due to hemispherical shell. Okay, find out. Let's see any help of that we'll get at center. But where is other shell? Other shell is not, the mass of other shell will not be here, no, at point 2. If you cut like this, where is the mass of this right part of the shell? Will not be at O, no, will be somewhere here, no. So what we should do now? We should calculate the field. We should calculate field due to hemispherical shell in this region. I think it will be very difficult. The mathematics will not permit us. At point O, we can find out due to hemispherical shell. But again, what happens? You should draw a semicircle of radius capital R. You should draw a semicircle of radius capital R. Then at this particular point, you should calculate the field. You should assume a small element here on this hemispherical shell. Then at various points, you should calculate. I think this will be really, really, really very difficult. What is alternatives available? There's one integration approach. Okay, totally ruled out. What do you mean by large sheet? the idea of large sheet in terms of physics is what do you mean by large sheet? No beginning, no end. I agree. So what do you mean by large sheet? No beginning, no end. That's the meaning of large sheet, no? No beginning, no end. Agree this? Will I agree this? If you say S, I think our 90% of problem got over. Last sheet here. Now, this thin shell is also similar to last sheet only. Because there's no beginning, no end. Where is the beginning for this? Nowhere is there. Where is the end? Nowhere is there. So then if I go and check it, no, the field will be produced by the thin shell. Let's analyze here. So what is the field at just on the point P here on the surface? We know we are very good in that. What is the field at point P? Just on the surface, GM by R square. Will I agree this? GM by R square. In terms of sigma, if you bring in terms of sigma, so M is equal to sigma 4 pi R square. Four pi sigma G by R square. R will not be there, sorry. Yeah, 4 pi sigma G. Will I agree this? The field strength at point P. Now, what is the field strength at O? Is 0. So there's a background. Everyone knows, I think. What is the field inside the shell? Will be 0. Field just on the surface of the shell. This one. So where is the point P? Point P is just on the surface. Means surface, no, just above it. Just above the surface you put it. Just And I'm saying that what is the last sheet? No beginning, no end. I'll say that this is similar to last sheet. Now, how come field is zero? So if you look at actually how field is zero, if you look at this shell, because it's a no beginning, no end. So this will be like a shell. So this will be like a sheet. There's a point 2 and this was the point P. No? So let me call the surfaces as 1, 2, 3 like this. So let me call this surface is 1, 2, 3, 4. What is the field due to large sheet? E1 equal to E2, E3 equal to E4 should be equal to 2 pi G into sigma, or 2 pi. So this will be the field, no? How the field at point 2 is 0 means because of 2 and 3 is 0. Field at point P will be superposition of E2 and E4. Okay, now justified. This is another way of thinking. Thin shell means you can also think like it's like a last sheet only. Because what is the last sheet? No beginning, no end. You're also same thing. How field is 0? Because I think this was the biggest thing that was troubled you. No, I'm giving some very beautiful explanation. The field at point O is 0 because E3 and E2 will be equal and opposite. The field at point O is 0. What is the field strength at point P? Just outside just above the surface of point P, E2 and E4 will undergo superposition. We are getting the field. Okay, got this. So now, so let's get into the problem here. Like, what is the force exerted by the one off on the other off? For that, what I do is like, I'll take out a small elemental area. Field at point P just above the surface, or you can put on the surface, just above the surface. I think in limits, you better take it. R just above the surface, it will be GM by R square. On the surface, GM R square, just above, English language, just above. Suppose R equal to 10 centimeter, 10.0001 centimeter. Still the field will be GM by R square only. Now I'll go into the next one more idea. I removed a small surface. I think this will be cap, no? This cap, I removed a small surface here. So let that be dm. The field as usual, this will be E2, this will be E1, no? This will be E2 and E1. So this elemental surface dm, what will happen? When I remove that, will experience force due to this. Will experience a force, that this elemental surface. So what I'm asking is, you assume a one elemental, I think it will become a cap, not like a arc. So I think everywhere, not a ring. Somebody is saying it's a thin ring. No, this will become cap, spherical cap. When you remove that spherical cap, the spherical cap will assume a mass, will have a dm that will experience force due to this, or else you can show that spherical cap here only. That spherical cap will experience force due to E2. So what is the force on that one? The force on that, force on small elemental area of mass dm is equal to df is equal to E2 into dm. What is the value of E2? What is the value of E2? Just now we have concluded, 2 pi sigma g into dm. What is the dm? Mass of that should be called sigma into dA. Okay, get this. This will be sigma into dA. So what is the gravitational pressure? No, gravitational pressure Gp is equal to df by dA. So this should be equal to 2 pi g sigma square. How do this pressure will act? Radially outward, radially invert at all points. Let me. This all about the diagram. Nothing to say. Mathematics is very simple. It will be exerting force like this. The gravitational pressure. The force exerted by one off on the other off will be like this. See, like now this off, the left off will exert force on the right off by these arrows. Similarly, what are these arrows? Force experienced by the left off due to right off. Altogether, I'm showing it here. Okay, got this. So again, don't think, sir, nobody is here. How this force will come? No, this force is what? This force, this half will exert force on this, and this half will exert force, and that arrows is what I'm showing it. Now, what is the effective net force will be? Gravitational pressure into effective area. What is the effective area? What is the effective area? It will see not 2 pi r square, it will be pi r square. This will come, I think, in fluid statics, no? When you go for that effective area, you look at the moon. So it's a solid sphere, but what is the effective area you are encountering? Like a disk, the similar thing, what happens here? This is some hard way of thinking. No, sir, this is something really very difficult. Okay, you can do one thing. You can try by another method because already you know field. So can we assume that I'll show by another method. This will be a little bit because all these ideas again when we go for electrostatics, no, there plenty of use will come. So the similar problem, let me solve by another method here. So there's a so let me take a one ring, I'll assume it. Let me assume a ring. I didn't draw properly. Yeah. Okay, this I'm asking to assume a ring like this. Okay, this will subtend. Let this be theta, d theta. Let this be dx. Here again, idea is same. if you take a thin shell, we'll get the field like this, no? E dash. The same problem I'm showing by another method. This will help us a lot. The previous one will little bit very difficult. This is what I feel very useful for you. So what is this? This is a thin circular strip. There's everything is a shell. So shall we say that this E dash, shall I bring it here, radially inward, and it will make angle theta. Similarly, E dash should also come here at this particular point. Here also it should come. So I'm just showing that. So what is E dash? What is E dash? First, the value of E dash, 2 pi sigma into G. What is the net field? 4 pi sigma G. So E dash is what will produce this particular thing, this element. Here I am assuming that one. Now let's get into this one here. So what is the force acting on that element? dF, force on the circular strip. Force on the circular strip should be E dash into dm. What is E dash? Already we know value. Sigma into 2 pi sigma into G. dm, what is the mass of that one? Sigma into dA. What is dA? Area of that circular strip. I think it will be quite easy, no? So what is that area? 2 pi sigma. What is dA? dA should be equal to 2 pi r into ds. So what is dl? I'll write it. What is dl? dl will be r d theta. Okay, now I think some very important thing. How do this force will act? You have to bring your this force is a vector quantity, no? On the ring, the force at every point, the force is acting in this direction. I don't know, three-dimensional not possible. At least at 2 points, I'll show it. Better to show at 2 points. This will be E dash, and this is the circular strip. What will happen to X component? What will happen to Y component of the force? Will cancel out, no? Only the X component will get added up, no? So when I write dF, what it should be? E dash cos theta or E dash dm. If you intentionally, I just left it so that you should think here, because if I write it, no, you feel okay, some mathematics it has come. How the field will be acting radially? Now which force component of you resolve this force? So there are two forces will come, no? I'll give the diagram. I think most of you are not able to understand. E dash cos theta will come like this. Okay, I'll give two diagrams. In different planes, we'll make observation of this. This is a circular strip. That E dash cos theta will be in this direction. Already, I think this you have come across the force of interaction between the ring and the rod. This is one thing. What about E dash sin theta? E dash sin theta will act radially inward. Everywhere it will be radially inward. This is what E dash sin theta. At all points, E dash cos theta. So what is this force? E dash sin theta, due to E dash sin theta, the net force on the circular shape should be 0, no? Due to E dash cos theta will get added up. Go back to the ring and the rod interaction. So therefore, is it writing E dash dm or E dash cos theta? E dash cos theta. Agreed, all of you? This is what mistake usually students will do here, because they don't draw diagrams. Until you don't draw diagram here, not possible. What is this? This is a circular strip, which blue color. In different planes, you should make observation. So that cos theta should be brought here. Sigma into dA. Sigma into dA. What is dA? 2 pi r d theta. So here also one cos theta will come. What is smaller? Smaller we assumed it here. So sine theta 2 pi r. Okay, one more because dl also we have introduced, no? I'll remove it. Okay, directly we'll write theta r d theta. What is sine theta? Smaller by capital R. So smaller, shall I write it? Capital R sine theta. So this will become df is equal to 2 pi sigma g cos theta 2 pi r sine theta r d theta.
So there should be another sigma.
One more sigma will come here, no?
Yes, sir.
Here it should be there. Yeah. Sigma into this is 2 pi r d theta. Before 2 pi should come. Check it everything. So here's smaller I should replace, no? Smaller is r sin theta from this triangle here. Okay, this will become 4 pi, okay, 2 pi square sigma square g 2 sin theta r square is also there. Look at this. Those who are not having that pressure effective area, no, that is alternative. Now what should be the limit? 2 pi square sigma square g r square, everything. Okay, what should be the limit now? The limit I'm going to put 0 to 90 degrees. So this will be minus cos 2 theta.
Sir, minus cos 2 theta by 2, no, sir.
2 will be there here. So this will become everything 2 pi square sigma square r square g. Is it same answer? Check it, same answer. It's the same answer, no? So I suggest you this method will help us a lot when we go for application.
Sir, initially we have to take 2e cos theta dm, no, sir.
Oh, is it force acting at only 2 points or at everywhere on the circumference?
Everywhere, sir.
Everywhere. Huh? Then E dash cos theta into dm, no? What is the dm? Dm is mass of this. I think the mathematics.
Okay, sir. Okay, sir. Understood, sir.
So that's why I don't want to show this E dash because this will mislead students. I'll take it out. Just can be asked in exam. Force exert by one half on the other half. So what is the idea here? That we are assuming that, what is our assumption? We are assuming that the right half of the shell is present in the field of the left half of the shell. Okay, I think I just spent enough of these things, no? So almost all basic ideas I gave it. So what do you mean by last sheet? Okay, no. So like, but where is the last sheet? I'm not sure. What do you mean by last sheet here? No beginning, no end. This thin shell will behave like a last sheet only. That's why the field inside is zero. How it is zero? Because E dash, these two will cancel out, you see. And this is something very important. Why I'm stressing this? The same idea I'll bring again in electrostatics. The same idea again I'll bring in electromagnetism. The same idea again I'll bring in surface tension. At several places, sometimes this idea will be brought here. So let's learn in the beginning now only. We'll be on safer side. Okay, this is about the overall, the gravitational pressure. Any application problems can also be asked here. Not only pressure on the sphere, everything on the shells like this also it can come. Now let's take some application problem. I'll go back to the our, I think time is there, no? One problem will take it. This is some, for Kepler's law, there's one question I'm taking it. Okay, let's discuss this one.